Hello everyone and welcome to the last video on this GeoGebra for EMT series. So in this video we'll be seeing how we can implement electric field intensity and electric flux density, the two concepts E bar and D bar using GeoGebra. So we all know the field intensity is nothing but force per unit charge. So we have seen the force equation which is Q1 Q2 K by R square into the unit vector AR. So if I want to find now the strength of electric field intensity at point P due to the charge Q1 which is placed at point A, then the formula for E bar will be the same formula of F. You have to divide it by Q2. You're removing Q2 and placing a point P there where the intensity needs to be calculated. So the intensity equation becomes K Q1 by R square AR. Okay, so we'll implement this using GeoGebra now. So in the previous video, we have already completed the force value, which is Q1, Q2, K by R, this capital R. By mistake, if I've written small r in the previous video, when you implement it, please change it to capital R, okay? Because it is supposed to be distance, not vector. It's a magnitude here, right? So we have implemented the force equation in this. Now we'll continue from here. All you have to now do is to plot E, divide the force by Q2. Okay, in the equation of force, Q2 needs to be removed. So I'll take it as E, which is equal to vector of, I need to start from A and not from origin. I don't want the vector equation to start from A. It should be plotted from, it should not be plotted from origin. I need to change to A. So starting point is A. After that, A plus, I'm doing this addition because starting point is A, and from here the intensity needs to be plotted, right? So to already existing A, I need to add the location of E. Okay. And to calculate E, what we have to do is divide F by the second charge Q2, right? So as soon as I do this, you can see there is a line extended from B. But why this line is not coming within the plot? The reason being, if you look at the values of E here, they are in thousands. It is quite large value which does not fit into the scale that is available here. So what you can do is divide this E value F by some maybe 100 or so that it fits to the scale. If it is still not coming into the diagram, maybe I can try a little more. Yes, I'll just reduce 1 0 here. Now you're able to see this arrow, right? I'll label it. So click on this settings, show label. Okay. So you can see this is your E. E is here. It is shown here. Zoom it a little. So this is your E. If you have a positive charge, if you have positive Q1, if Q1 is positive, the intensity will be away from it. Okay. And if I change this charge value, let me make it as minus. Please observe the changes in this arrow, okay? When I make it minus, the intensity changes. The force is also changing, intensity is also changing. So if the charge value is positive, it will be away from the point. If the charge value is negative, it will be towards the point. Okay. This is how you can find intensity, plot intensity in this GeoGebra. Coming to the last part, that is flux density, D bar. So D bar is nothing but epsilon into E, where epsilon will be epsilon naught, epsilon r combination. But if I'm doing for free space, it becomes just epsilon naught, whose value is this. So we'll try to include this also here. So to find D, first I need epsilon value. Let me take it as E, or I'll write it as EPS, epsilon, which is equal to 8.854. For 10 power, I should write E minus 12. So you're getting this value. See, I'll go to settings and again settings here. If I change it to 5 decimal places, you see the epsilon value was supposed to be 8.854 into 10 power minus 12, but it is approximating it to 0. Okay, so that's why I told you, please change the settings here. You just have to go to settings, again settings here, and then extend the number of decimal places so that you will be getting the most accurate result, not approximate result. Okay, so now we have epsilon. All you have to do is find d, which is equal to, I'll directly plot it. Okay, instead of just calculating and then plotting, I'll directly plot the vector starting from a, comma, so starting from a, comma, a plus, mm, t is nothing but epsilon EPS multiplied by E. Okay, now if I enter, you should be able to see one more arrow coming into picture. We'll see if it is there. Go to settings, show label. Yes, you can see D is also plotted. If you are not able to see it, if it is not visible, you please multiply it so that you can, so many zeros are there. No, it is a very small value. You can push it a little bit further. So I'll multiply it with a bigger number so that I'll be able to see. I'll have to multiply with another, yeah, bigger number. Mm, okay. It this became too much. Yes, now we can see both arrows coming here. If this arrow, if I click, it shows me which one it is. This is for E. If I click on this arrow, this is for D. Okay, this arrow is for D. E and D will be along the same direction. Okay, this is how you can find force, plot the force, electric field intensity E and electric flux density D. So this completes the basic concepts of electromagnetic theory using GeoGebra 3D. Thank you. Yeah, in case you have any doubts in any of these concepts, you want me to repeat any of the topics,